Is the earth flat? Some people seem to think so, or at the very least, think it is worth questioning. Spoiler alert, the earth is not flat. But before you laugh and move on dismissively, let's understand why some people still believe that in this modern age. Why they choose to stand at odds with what most people consider obvious. And why should we care about it? Because this is not really about the shape of the earth. It is about something much more relevant to everyday life. How human beings decide what is true. How smart people can sometimes believe strange things. And whether skepticism protects us or misleads us. So let's start with something important. Why flat earth feels convincing. Because at first glance, if you think about it, flat earth does sound convincing. Think about your everyday life. When you walk outside, does the earth feel curved? No. Scientists tell us that the earth rotates at about 1670 kilometers per hour around the equator. Yet none of us feel that movement. Look at the ocean, look at any lake. Everything appears flat. So from a purely human perspective, the idea of a flat earth starts from something very powerful. Trust your own eyes. And honestly, that instinct isn't unreasonable. Most of us trust direct experience more than complicated explanations. If reality looks flat, then asking questions isn't irrational. This is one of the biggest misunderstandings about flat earthers. Many people assume they are stupid, but that explanation is lazy. A lot of flat earth believers are actually skeptical and curious people, and they do sometimes tend to be quite distrustful towards institutions, general science, or the government. Researchers from the University of Melbourne, studying why some people adopt alternative beliefs, found that distrust in institutions can make people more open to explanations outside the mainstream. People who think, what if everyone else is blindly accepting something? And to understand the movement, we have to take that mindset seriously. So, what exactly do flat earth believers believe in? What do they think? Well, there isn't one single version, but the most common model looks something like this. The earth is a flat disk. The North Pole sits roughly in the center, and Antarctica is not a continent at the bottom of the globe, but rather an enormous ice wall surrounding the edges of the world. According to many flat earth models, the sun and moon are not distant objects in space. Instead, they are smaller, closer, and more above us. Gravity itself is also quite controversial in these circles. Some reject gravity completely. Some argue that density and inertia explain why things fall. And many believe that major institutions, especially space agencies, are misleading the public. Now, before we continue, here's an important nuance. Flat Earth is not really one perfectly consistent scientific theory. It's more like an ecosystem of skepticism. Different believers disagree on details, but they all share one belief. The mainstream story about reality cannot be trusted. And that idea turns out to be much bigger than just geography. So let's look at their arguments fairly. Not strawman versions, but the actual strongest ones. Argument number one, water always finds its level. This is probably one of their biggest arguments. Their claim goes like this. So if the earth is a giant spinning ball, why don't oceans curve dramatically? Why doesn't the water fall off? After all, water seeks level. It seeks to be flat. At first it sounds convincing, but here's the misunderstanding. When scientists say level, they don't mean perfectly flat like a table. They mean level relative to gravity. And we all know the classic illustration. Imagine an ant on a basketball. To the ant, its surroundings look perfectly flat. The surface would feel almost completely flat. And it's the same about our Earth. The circumference of our Earth is close to 40,000 kilometers. And the Earth is so large that at human scale, the curvature is very subtle. You usually don't notice it. And the argument number two, we can see too far. Flat Earth believers often point to distant buildings and mountains visible over huge distances. Their argument is, if Earth curves, shouldn't these things disappear? Sometimes they seem visible anyway, but reality is more complicated. Light bends, atmospheric refraction can distort what we see. Temperature differences in the air can make distant objects appear lifted or stretched. But one thing consistently happens over long distances. Objects tend to disappear from the bottom upward, which is exactly what we would expect on a curved surface. It's why ships vanish hull first over the horizon, not top first. Argument number 3. We don't feel the earth moving. And honestly, this one feels relatable. The earth supposedly spins incredibly fast, thousands of kilometers per hour. It is rotating on its own axis and revolving around the sun. So, why don't we feel all that motion? The answer comes down to something very simple. We feel acceleration, not constant movement. Think about sitting inside an airplane. As it takes off on the runway, we feel that acceleration and inertia. But when it is actually in the air, we don't feel it. We can just sit and stand and walk normally. We barely notice that we are moving hundreds of kilometers per hour. Motion itself isn't what we feel the change in motion. And the final argument number 4. NASA lies. Now, this one gets interesting because institutions have lied before. Governments have lied, corporations lie, and history proves that. So, skepticism itself isn't irrational. But here's where things become difficult. For flat earth to be true, the conspiracy would have to involve governments, scientists, pilots, astronomers, telecommunications, GPS systems, satellite companies, universities, weather forecasting, and countless independent observers across the world, all coordinating perfectly for decades without any undeniable proof leaking. At some point, the scale of the conspiracy itself becomes much more harder to believe and unfathomable than the concept of a globe. And perhaps the bigger question becomes why? What exactly would be the motive? So, we all know what the truth is about the earth. But one mistake people make in this debate is relying too much on authority. Scientists said so, NASA said so. For someone skeptical, that usually doesn't work. What works better is asking what can ordinary people verify. For example, time zones. Why is it daytime in one part of the world and nighttime somewhere else? Take lunar eclipses for example. More than 2000 years ago, the Greek philosopher and astronomer Aristotle noticed something curious. Whenever the earth passed between the sun and the moon, the shadow cast on the moon appeared curved consistently, no matter the angle. Now, a sphere naturally casts a curved shadow from every direction. A flat disk does not. Then there's the night sky. Depending on where you live on Earth, you see different stars. Someone in Australia can observe constellations in the night sky that people in India or Europe simply cannot see. It is not visible to them. The famous Southern Cross constellation, for example, is visible in the southern hemisphere but not most northern regions. And then there's modern technology, GPS systems, satellite internet, weather forecasting. Thousands of systems quietly rely on orbital mathematics every single day. You don't necessarily have to trust institutions blindly, but you can test many things yourself, and that distinction matters. At this point, you might ask, if the evidence is so strong, why does flat earth still survive? And honestly, that might be the most fascinating part. Because flat earth isn't really just about earth, it's about trust, it's about identity, about belonging. For some people, discovering flat earth feels like waking up, like becoming part of a hidden truth. And social media algorithms make this even stronger. Watch one conspiracy video, and suddenly your feed becomes an endless rabbit hole. But beyond that, there's something deeply human happening here. People want certainty, people want answers, people want to feel like they understand a chaotic world. And sometimes, alternative explanations feel emotionally satisfying, even when they struggle scientifically. So, is the earth flat? The overwhelming scientific evidence says no. But maybe that's not the most interesting question. Because flat earth isn't really a story about geography, it's a story about skepticism, distrust, community, and the strange way human beings search for certainty in an uncertain world. Perhaps here the lesson is not never question anything. That would be dangerous. Questioning ideas is healthy. Questioning institutions can be necessary. But skepticism without standards can become just as misleading as blind belief. And maybe the real lesson here is not to mock people for asking questions, but to learn how to ask better ones. What evidence changes our minds, and what merely confirms what we want to believe? What do you think?